Hello everyone, this is the second lesson for chapter 8. This is for 8.2. You recall that in 8.1 I showed you how to figure out the estimate for the population mean when you know the population standard deviation. In this lesson I am going to show you how to figure out the population mean, how to estimate the population mean when you don't know the population standard deviation. That's typically the scenario in the real world because you don't have enough information about the population to know the population standard deviation. So how do you deal with something like that? Now, what we saw in 8.1 was this, okay? To create a confidence interval, your formula is this: x bar plus or minus z sub alpha over 2 multiplied by sigma over root n. Now in this section, to figure out the confidence interval when you don't know the population standard deviation, your formula is a little bit different, and it's what I have down here. You can see what's different in there. Instead of sigma, you have little s, which is the sample standard deviation, and instead of z sub alpha over 2, you have t sub alpha over 2, and I'm going to show you how to figure that out. That's your t value. The table is a little bit different. You have it in your formula booklet. I'll show you where it is. And then you have the degree of freedom, df. It's called degree of freedom. And to calculate that, it's your sample size minus 1. The assumptions are fairly similar to what we had previously. The assumption is that the population standard deviation is not known, but the population is still normally distributed, and the sample size in this case is small. Your n is it in this case. It will not necessarily be up to 30 in this case, because the population is assumed to be approximately normally distributed. Now, the interval I have here, don't be confused by it. It's just this, okay? It's just x bar plus or minus t sub alpha over 2 multiplied by s over root n with a degree of freedom of n minus 1. The difference in the picture in this one that we have here and the one we had before is that you can see instead of having z sub alpha over 2, we are going to have t sub alpha over 2. I will show you how to find that. And instead of having negative z sub alpha over 2, we are going to have negative t sub alpha over 2. The confidence level is 1 minus alpha, which is like 90% or 95%, 99%, and so on. The table we are going to be using is not the usual one, the Z table. This one is called the student T table. Okay, the T table is what we're going to be using. I will show you how to use that table. Now, that formula is after the normal distribution formula in your table, the Z tables. The one right after that is this one. Okay, is the T table. And to use this table, across the top, right, as my arrow is showing there, it tells you the areas that you are thinking about. Okay, so that's your t sub alpha over 2. Okay, so sometimes the area there is 10%, which is 0.1. Sometimes it's 5%, which is 0.05. Sometimes it's 2.5%, 0.025, and so on. And on the left side, left column, you have the degree of freedom. That's what that is. You can see at the top of the column you have df, right? So these are the values for the degree of freedom. And in the body of the table, those are your critical t values that you are going to be looking for. So when we do example now, I'm going to show you how to use this table. For example, the owner of a large equipment rental company wants to make a rather quick estimate of the average number of days a piece of ditch digging equipment is rented out per person per time. The company has records of all rentals, but the amount of time required to conduct an audit of all accounts would be prohibitive. The owner decides to take a random sample of rental invoices. 14 different rentals of ditch diggers are selected randomly from the files, yielding the following data. The owner uses these data to construct a 99% confidence interval to estimate the average number of days that a ditch digger is rented, assuming that the number of days per rental is normally distributed in the population. So, as you can see in the question, what we are trying to figure out here is a 99% interval estimate telling us what is the average number of days a typical renter will rent the equipment out for this company. Like we said previously, to create a confidence interval, the formula for creating a confidence interval is as shown. It's the sample mean plus or minus the critical value, t sub alpha over 2, multiplied by the sample standard deviation divided by the square root of n, where n is the sample size. Okay, so the information we have here, now the data is provided for us, right? So from that data, you can calculate your sample mean, x bar. You will recall that in chapter 3, we have talked about descriptive measures of data and how to calculate some of these descriptive measures. One of the most basic ones was the sample mean. To calculate mean, just add together all the data values and divide by the total number of things you have in the set. So if you do that for this data set, you will see that your sample mean is 2.14 days. Also, your sample standard deviation is not provided for you, but you have the data. You will remember also that in chapter 3, we can calculate the standard deviation for ungrouped data using the formula as shown. So if you use that formula to calculate the standard deviation, you will get 1.29 days. And we know that the number of things in the sample data is 14, right? N is 14 in here. So now, all the information we have as shown. The confidence level for the problem is 99%. So confidence level is 1 minus alpha, which is 0.99. That means that alpha is 0.01 and half of alpha is 0.005, which is 0.5%. That is the area you are going to have in the tails for the data. And the degree of freedom for this example, like I said, is n minus 1. How to calculate that? N is 14, so n minus 1 will be 13 is your degree of freedom. So the picture we're looking at is this one, right? The distribution is supposedly normal, and the area in the tails is 0.5%, and I've indicated those in here. That means that the area between the middle, the mean, and this t value we're looking for is 0.4950. That's 49.5%. You will know that half of the distribution is 50%. So if you take out half from 50%, you'll get 49.5, which is 0.4950. And so we need to figure out the t value that corresponds to an area of 0.5% in the tails. How do we do this? Well, the table of values we're looking at is this t table, like I showed you a few minutes ago. So all you have to do is, since we know that our t sub alpha over 2 is n minus 1, that is t sub 0.005, 13, that's what we need to figure out. We will just take a look at our degree of freedom. The degree of freedom is in the first column, d sub f, df, which in this case is 13. So look for 13 in that first column, as I've shown that over here. And then the area in the right tail is 0.5%, which is 0.005. So look for that across the top, and I've shown you that up here as well. So like we used to do, or like we did with the Z tables, just cross the column and the row where the degree of freedom is and the area. So cross them in that way, and you will see that where they intersect, you have this value there, 3.012. That is our T critical value that we're looking for. And instead of the Z that we used in 8.1, we will use this T value for our confidence interval. So back to the problem, we have all this information now, and we have just found our T value, which is 3.012. So we will just make the substitution in our formula for confidence interval as shown, and using our calculators, we can calculate that error range is 1.04, right? So 2.14 plus or minus 1.04 is our confidence interval. So if you subtract 1.04 from 2.14, and if you add 1.04 to 2.14, you will get this interval. That means that we are saying that a 99% confidence interval will give you a range of between 1.1 and 3.18 days. That is a 99% interval estimate. Now, suppose some person says, oh, for this company, the average number of days the instruments are rented out for is 2 days. Suppose the person said that. Will they be correct or not? They would be correct, because the interval 1.1 to 3.18 contains 2 days in there. 2 days lies in that interval. So that assertion will be correct. Unlike if another person made a statement and said the average number of days the instruments were rented out for was 5 days. If somebody said that, that would not be correct, because 5 days is not in that interval, it's outside of it. That's how you would use your confidence interval. Let's see another example. All right, sorry about that. So we're looking at another example now. Second example. According to Ronzheimer International, the average cost of a domestic trip for business travelers in the financial industry is $1,250. Suppose another travel industry research company takes a random sample of 51 business travelers in the financial industry and determines that the sample average cost of a domestic trip is $1,192 with a sample standard deviation of $279. Construct a 98% confidence interval for the population mean from these sample data. Assume that the data are normally distributed in the population. Now go back and examine the $1,250 figure published by Ronzheimer International. Does it fall into the confidence interval computed from the sample data? What does this tell you? So let's tackle this one. Well, the first thing here to note is that we are trying to create a confidence interval. That's the first part. We are trying to construct a 98% confidence interval. These guys are saying that, the average cost from their sample, was $1,192 with a standard deviation of 279. And we're trying to compare that with what Ronzheimer International said the population average was. That's what we're trying to do. The information we are provided with, we have the sample mean, which is $1,192. The sample standard deviation is $279, and the sample size is 51. The confidence level for the interval we're trying to create is 98%, so 1 minus alpha is 0.98. Alpha is 0.02, that's 2%, and half of that is 0.01, which is 1%. With a degree of freedom of 50. Remember that degree of freedom is n minus 1, which is 51 minus 1. That's 50 in this case. So given all this information, all we have to do now is our picture that we are thinking about looks like this, right? The areas and the tails is 1%. That means from the middle to the t value we are looking for, that area is 49% or 0.4900. So in our t table, the area in the tail is what we are going to be looking at, right? 0.01. And like I showed you previously, we are going to use this table of values to figure that out. Across the top, you have the area in the tail that you are looking for, which is 0.01 in this case. And on the left side, we have the degree of freedom of 50. If we cross these two values, you will see that they will meet at this point, 2.403. Which means our t value is 2.403. That's our critical value. If we now go back to our confidence interval that we're trying to create, we have found our t value now. We can now substitute in our confidence interval formula x bar plus or minus t sub alpha over 2 multiplied by s over root n, which will give us this interval here. And if we use our calculators, we'll see that the error range is $93.88. So 1,192 plus or minus 93.88, which will give you an interval that looks like this. That means that the population average number or cost that this company is coming up with, the average cost lies in this interval between $1,098 and $1,285. That is the 98% interval estimate. Now, to answer the question, the other question, how correct is Ronzheimer International's assertion? You remember they said that the average cost is $1,250. Are they right or not? How right are they? Well, the question to answer or to figure out if they are right or not, the interval that we have created from this data, does it contain $1,250, which is the assertion that Ronzheimer International made? You will see that $1,250 lies in this interval that has been created. So that means that the assertion that Runtaba International made is correct. I hope this is clear to you. What I'd like you to do now is for you to try an example by yourself. So I have an example here. Like we did in the previous videos, what I would like you to do now is please pause this video now and try this example. When you finish, you can continue the video to see what I have done. So please pause the video now. Okay, so what did you do? Let's read the question first of all. A random sample of 15 items is taken, producing a sample mean of 2.364 with a sample variance of 0.81. Assume X is normally distributed and construct a 90% confidence interval for the population mean. So what we're trying to do here is create a confidence interval for the population mean. The formula for our confidence interval is as shown: x bar plus or minus t sub alpha over 2 multiplied by s over root n. Because we don't know the population standard deviation, that's why we're using s. The sample mean in this question is 2.364, but we don't have the standard deviation given to us. We have the variance. But we know that the relationship between variance and standard deviation is that one is the square root of the other. So standard deviation is the square root of the variance, which will give us 0.9. And the sample size is only 15. The confidence level is 90%, which will give us alpha, which is the area in both tails, is 10% at 0.1, half of which is 5%, 0.05. The degree of freedom is n minus 1, which will be 14 in this case. The picture we're looking at looks like so. The area in the tail is 5%, is 5%, 0.05. So we want the t value that corresponds to that area. And like we said before, if you go to that t table, like I showed you, and you figure and you look for the area in the right tail and cross that with the degree of freedom, you will see that your t value is 1.761, which we can use in our confidence interval formula to get a confidence interval that looks like this: 2.364 plus or minus 0.41 to give you an interval of 1.954 less or equal to mu less or equal to 2.774. I hope you understand this, and I hope it's clear to you. I will put up some assignments on Wiley for you to do to cover 8.1 and 8.2.